Hello everyone and welcome back to Tech Talks at VMworld Barcelona 2012. Our next presenter is Rob Tribe with Nutanix. Rob, I'll go ahead and we had a little slow start, so I'll just go ahead and let you get to it.
No problem, thanks very much. So thanks for inviting us to come and talk about how Nutanix is a perfect platform for scale-out cloud provision. So just to start off, my name's Rob Tribe. I'm the Senior Systems Engineering Manager with Nutanix. Previously worked for VMware for 7 years or so, and EMC and so on. And what we're going to have a look at today is the Nutanix platform from a technical perspective to see how that fits perfectly with a scale-out cloud provisioning platform. So we got our inspiration from the Google file system. Our founder, Dr. Mohit Aron, he spent 5 or 6 years working at Google, leading the design and implementation of the Google file system. So what we have tried to do is to bring that scale-out goodness to the rest of the applications within the enterprise. So what we mean by that is we have a linearly scalable enterprise platform that literally goes to hundreds of nodes, supporting both the virtualization platform, so the virtual machines, and the storage as well. There's a single view for all the storage within that platform, and it means that we provide all of the storage as a single whole. We provide that out of local storage within each of the nodes within that platform, and we do that without the use of any storage area networking, any kind of SAN, those sorts of things. And it provides for a very scalable performance platform that's tolerant to hardware failures and allows you to scale out from literally hundreds of nodes to thousands of nodes. So what does it look like? So literally we have a controller virtual machine on each of the servers within the platform, and as you can see we go to n numbers of servers, and you can think of a controller virtual machine as a storage processor. So we've taken all of the goodness that you'd expect to get from an enterprise platform, so such as snapshots, replication, zero overhead cloning, all those sorts of good things, and we've provided all that functionality out of standard local storage within the x86 platform. So it's all super converged into one 2U chassis that just scales out massively. Each node within the platform provides all that storage, so 5 terabytes of storage within each node, and is absolutely hyper-converged. So, we see 2012 as being the year where we start getting some real convergence within the enterprise platforms. So it's modular, so we have compute and storage within every single node. So a node contains dual socket Intel servers, up to 192 gigs of memory and 5 terabytes of storage. But it delivers extremely highly performant random I/O as well. So we make use of the Fusion I/O card within that, within each of the nodes within the system, to serve out to the virtual machines all the hot blocks of data that are being delivered to those VMs. It's completely integrated, so when it hits the floor, ESX is installed, it's all fully configured, there's actually nothing to do. So we can get one of these things running within about 20 minutes to half an hour. Literally, it's just a case of applying IPv4 addresses to the system and bringing it online. So it's very, very easy, to get one of these things, get going, and start scaling out massively. And what we provide really is a distributed file system across all those nodes within the cluster, providing that single scale-out file system from local storage within each node. So what does the device actually look like? So very, very high density. Within each 2U block, there would be 4 SSDs, so 300 gigabyte SSD drives, 4 Fusion I/O cards, and 20 terabytes of 1 terabyte hard disk drives. Again, across that cluster, 8 sockets of Intel processors, 4 ESX servers, and effectively 4 virtualized storage controllers. All those enterprise features that you'd expect to get from a storage array network and from an enterprise SAN are available but delivered via this local storage. So what are we doing? We're delivering a SAN-free compute and cloud platform that's massively scalable and provides very predictable performance. We've completely flattened the architecture of the delivery, so we literally just have Intel x86 servers with local storage connected to top-of-rack 10 gigabyte switch, and away you go. So there's no backplane, there's no InfiniBand connections, none of that stuff. Literally, it's just commodity Intel x86, top-of-rack 10 gig switching. And the magic that Nutanix provides really is that Nutanix distributed file system. So it transforms that local storage into a single global file system that can be accessed by any of the ESX servers within the cluster. And it fully supports DRS, HA, fault tolerance, all those things that you'd expect to get from VMware, and vMotion, absolutely everything. ESX has got no idea it's actually running out of local storage across that cluster. So it provides all the, the goodness that you'd expect to get from an enterprise SAN, but it also provides all the nice things that we like about local storage. So the things we like about local storage is it's low latency and it's very predictable. So back in the good old days, we'd deliver a server and it'd have some disks inside of it, and it would, we'd know exactly what the performance was going to be to that server. And then we started connecting things into SANs, connecting them to shared arrays and so on, and that's kind of when life got hard. So what we're really looking for is that scale-out performance where, we get all the enterprise features of a storage area network and all the predictable performance of local storage. So you can actually view it just like Amazon EC2, that kind of cloud provisioning. We fully support vCloud Director, and we can run multi-tenant virtualized workloads within that single platform. And it literally just takes a few minutes to get these things up and running. So what does it actually do underneath the covers to kind of achieve this? So if you look at the screen now, within each of the nodes we have a Fusion I/O card and a number of hard disks and a SATA SSD. And within that node, we have a Nutanix controller virtual machine. We raw device map the hard disks up to the Nutanix controller virtual machine. And we actually use PCI Express pass-through to get the Fusion I/O mapped straight into the Nutanix controller virtual machine. And that allows us to continue having that very low latency connect. What we then do is we take each of those nodes within the cluster, and we can have literally up to n nodes within a cluster, and we form all of that storage into a single storage pool. So the spinning hard disk drives, the Fusion I/O and so on, forms a single global storage pool. And so that storage pool is literally just a physical collection of disks across all those nodes, and as far as ESX can tell, all those ESX servers, that's just a single SAN. And we can create multiple storage pools within that, within the array, such that if you've got different customers who've got different storage requirements, maybe some of them need Fusion I/O, some of them don't, and so on, they can sit within their own unique storage pool, and we can physically segregate them up. Then within the storage pool, we create containers, and a container is literally a data store. So we don't have LUNs, we don't have volumes, we don't have fan-in, fan-out ratios, all those things. We literally then just export those containers as NFS data stores. So literally within 2 or 3 clicks of turning on one of these systems, you're provisioning virtual machines and you're provisioning storage. Very easy to do. We also support iSCSI data stores as well. So clearly, if you're running things like Exchange servers where you need block level storage, then we'll provide that through iSCSI also. So what does the I/O path look like as we're then doing this? So the guest virtual machine makes an I/O request to a data store. The data store is then redirected back to the Nutanix controller virtual machine. And then that Nutanix controller virtual machine redirects that I/O back through to the local storage. The Nutanix controller machine, though, aggregates all the storage within the entire cluster so that you see it as a single whole. Within the Fusion card, then we hold, real virtual machine data. Okay, real virtual machine data. We have the hot cache in there, metadata for the entire cluster is held there, and the virtual machines. Within the hard disk drives, that's where we store virtual machines as well. And the SATA SSD drive is where we store the ESX, that's the boot drive basically for ESX. Controller virtual machine sits in there, and virtual machine swap sits in there as well. So when a virtual machine writes to disk, literally it writes to the local storage, and then we replicate those blocks of data to other nodes within the cluster. And that's to ensure that we maintain high availability if any node or disk should fail. Obviously, a read I/O just reads locally. So as we're building one of these clusters out, we maintain very localized I/O within the node, such that as you're having large numbers of virtual machines within one node, they're not affecting the performance of virtual machines within other nodes in the cluster. So just to finish off, that's what the architecture looks like. It's massively scale out, preserves the goodness and predictability of local I/O that we all know and love, whilst it preserves the enterprise features that we like about, storage arrays such as snapshots, the single data namespace, replication, those sorts of good things. And literally we've only just started scratching the surface with what we're delivering in terms of, the functionality that we're going to deliver within this different way of scaling out both ESX servers and storage. Thank you very much.
Rob, I really appreciated that. That was very interesting. And I also wanted to thank Nutanix for being one of the sponsors for having the V Brown Bag guys come out and
Yeah, no, it's our
participate.
pleasure.
Is it bad? Oh.